Welcome to Lesson 3, Integrating and Leveraging AI Environments. In this lesson, we will go over hybrid AI labs, in other words, combining home labs and cloud resources. We will talk about synchronizing data and projects and leveraging the strengths of both environments. We'll run open source models or open weight models available on Hugging Face and explore tools like LangChain, Llama Index, embedding models, vector databases, and many others. One approach that you can take is using a hybrid AI lab, which is basically combining on-premises or your home-based lab with infrastructure that is within cloud-based resources, right? So this hybrid mode will basically offer the best of both worlds. Basically, you have the control and security on-premise and of course the scalability and flexibility of cloud platforms. The reality of today's world is that most organizations are using cloud platforms, and they're also exploring how to bring back some of the cloud capabilities on-premise because of the cost of AI. So the more that you're familiar with these implementations, the better for you. One of the beauties of hybrid AI labs is that they integrate the on-premise infrastructure that you have, your local servers, your infrastructure with the cloud-based resources from AWS, Google Cloud, and Azure that we were just discussing earlier in the course. In the next few segments, we're going to talk about synchronizing data and projects between your environment and in the cloud, leveraging the strengths of both environments, running open source models that are available in Hugging Face, and we started to actually do that earlier in the previous lesson, but we're going to go over a little bit more in detail about different model gardens, model playgrounds that you have within cloud-based environments, and use those models that are available, the open weight models that are available in Hugging Face. You're also going to be learning about how to use Hugging Face models in Ollama as well. Synchronizing data between projects home or in the cloud can be pretty complex in some cases, and in some cases it can be pretty simple, right? Depending on what you're trying to do and depending on where you're exploring and experimenting with. So in some cases, if you want to replicate a real world enterprise level workflow, then you need to explore different tools that are provided by some of these cloud providers like AWS DataSync or BigQuery, right, to schedule queries automatically in a specific period and so on. However, if you're doing something simple as basically playing with Ollama and a couple of open weight or open source models out there, and you want to take advantage of the low code or no code infrastructure by some of these providers, then you basically leverage APIs to enable seamlessly data exchange between systems, and then provide some flexibility for integrating cloud services with your on-premise solution. However, in some cases, most of these labs are done in isolation. So in other words, you're actually playing with some of the models, some of the libraries like LangChain, Llama Index, and many of the ones that I'm going to be sharing with you, on premise, with something like Ollama running a Microsoft, small language model like Phi or Llama and so on. Or in some cases, you're actually doing everything in the cloud and just have your development, environment locally in your lab, right? So in on premise. So it all depends on the scenario in here, but there are a few best practices for data synchronization, and specifically if you're now going over some advanced labs like for fine-tuning, for training a model from scratch and so on, you need to, whenever you're doing data synchronization, you need to maintain data integrity. So you have to use some type of validation process to ensure consistency across all your systems, right? You can implement distributed transaction management protocols like two-phase commits and so on, go to that level of detail, or have something very simple as just a hash verification whenever you're transferring files. Some of the cloud providers allow you to develop automated mechanisms to handle conflicts whenever you have even multiple users edit some data, right? For example, prioritize changes based on timestamps or user roles, etc. But if you're just doing a very basic lab, you probably don't have to worry about a lot of problems with data synchronization between many users, since you're probably going to be the only user. However, if you want to take it to the next level, as I mentioned to you, some of these providers like AWS, they provide solutions like DataSync, AWS DataSync, which is an online data movement and discovery service that simplifies and accelerates data migrations in AWS, as well as moving data to and from on-premise storage, edge locations, and even other cloud providers. If you have something in Google Cloud and you want to transfer it to AWS or vice versa, these types of solutions allow you to actually do that. But since this course is tailored for people that are just building simple labs, whether at home or in the cloud, I'm going to skip a lot of the details related to these tools like DataSync and some other providers in this course. In the next section, we're going to talk about how to leverage the strengths from both environments, on-premise and also in the cloud. So by now, you know that combining the capabilities of your home lab with cloud-based solutions definitely will offer you a powerful strategy for innovation, for upskilling yourself, experimenting, flexibility, and also cost efficiency, right? Each environment has its unique strengths that whenever you leverage them together, you can create a seamless ecosystem for AI development and of course for experimentation and for you to learn about the technologies. It is inevitable that you will have to interact sooner or later with a cloud provider, whether it is interacting with a model directly from a provider like Anthropic or OpenAI, or using the cloud environments that we covered earlier, like Google Cloud, in the case of Google Vertex AI, Bedrock in AWS, or Azure Foundry, right? So now the cool thing about the home lab is, of course, you can run tools like Ollama that we have been mentioning here really, really pervasively, right? Because it makes it easier than ever to run a language model at home on your personal machine on a system that doesn't require hundreds of CPUs or GPUs rather to run some of these foundation models. You can actually run Ollama and simplify the process of running open source LLMs locally or open weight models locally, like Llama, Vicuña, etc. Right? So you can customize them as well, even using the model file implementation within Ollama. And we will go over some of the technical details on that later. However, some of the advantages, of course, of home labs is cost control. There's no recurring cost for cloud compute resources. Also, the offline capabilities, so operating without an internet connection, ensuring uninterrupted access to the AI models, since they're actually running, at home. And of course, full autonomy, so complete control over model configurations and data handling. Now, the strengths of cloud AI labs definitely are obvious, right? So cloud platforms like AWS, Google Cloud, Microsoft Azure, they were not invented yesterday. They are very scalable, allow you to have on-demand access to high-performance GPUs and TPUs for training complex models. And then providers like SageMaker, Google Vertex, and Azure, they offer pre-trained models for tasks like image recognitions and very domain-specific things like translation or vision, speech, language processing, many other things that you can leverage out of the box from those environments as well. And specifically, not only with generative AI, but with traditional machine learning as well. So some of the advantages of the clouds, of course, is the compute power, the ease of integration. A lot of these, of course, they provide from cloud services like storage, like S3 buckets, or analytics tools, and things that you can incorporate within your AI deployment. And specifically nowadays, whenever you're trying to create agentic implementations, they also provide a low-code or no-code environment for you to start integrating your data and your workflows and your tools and allow them to operate on that data, of course, and create cyclical workflows for agentic implementations. So here are some recommendations. If you're doing just research and development, so if you want to just experiment with open source LLM locally, running Ollama, leveraging your ecosystem at home, I think that's the best use case for you to get familiarized with that. Or even if you want to get familiarized with vector databases like Chroma, pgvector, many open source vector databases that you can run on premise with your own data and research and development of your applications, definitely that's actually something that you can really easily run at home. Now, if you want to deploy something that eventually will be like a customer-facing chatbot or using quantized local models for privacy while relying on cloud services for advanced analytics, you can absolutely do that, right? You can combine local inferences capabilities from a home lab with cloud-based monitoring systems to enable real-time decision-making in things like IoT implementations, right? What we call edge computing, and nowadays we call AI edge computing. So again, depending on the ecosystem, there's a lot of pros and cons on each of those deployments. In the next section, we're going to go over how to run open source or open weight models available on Hugging Face. Hugging Face has become definitely the go-to place for the AI and machine learning community because it basically offers a very vast ecosystem of open weight and open source models. It also includes datasets, resources, papers, tutorials, many, many different things. But definitely a lot of people go there to take advantage of AI models that are open source and open weights that you can build a lab in your home, or you can, of course, use them in the cloud as well. We went over many different implementations in cloud providers, including Bedrock, SageMaker, Vertex AI, Azure AI Foundry. All of them have access to open weight models that are available in Hugging Face. You can load pre-trained models from scratch by actually using the transformers and the Torch and TensorFlow libraries and so on, or use things that you learn like Ollama. Running a model from Hugging Face in Ollama is extremely simple. You can follow these steps, right? So you already know that Ollama is a tool that is designed to simplify running and managing large language models or small language models locally, and it supports models in the GOF format. And basically, GOF stands for GPT Generated Unified Format. It's a file format that is specialized for storing large language models or small language models, optimized for fast loading and efficient inference, right? It's definitely something that was created for the popular Llama CPP, which at the end of the day is one of the foundations for open weight models out there. It became the inference framework for that. So one of the things is that you combine model parameters, so weights, tokenize their vocabulary, configuration attributes, metadata into a single file, and it simplifies the management and the deployment of these models. So you can use any of the GOF-based models created by the community and available in Hugging Face directly in Ollama. And to do so, the command is really simple. Basically, it's an Ollama run, and you put the URL of the Gov compatible model in Hugging Face, just like you're seeing in the screen. And that's it. You can actually run it locally in your system with no configuration of parameters, no configurations of any additional libraries and so on. And it cannot get any simpler than this. So this is how to run, or one of the examples of how to run a local model from Hugging Face using Ollama. Now, as I mentioned earlier in the course, there are different alternatives to Ollama for running models locally. Several excellent tools and frameworks that definitely you can take advantage of. Another tool is LLM Studio, and LLM Studio is also a very powerful ecosystem where you can run LLMs in your laptop or your desktop machines, chat with your local documents. So in other words, basically do a retrieval augmented generation, and even use models in-app through a GUI or an OpenAI compatible local server, which is pretty nifty in there. So LLM Studio is, or LM Studio is another very popular tool out there. The one that we covered earlier was Local AI, which is another alternative to Ollama, and you can run it also in a Docker container, just like you see in the screen here. So different alternatives for running local models, but one of the most popular definitely in the community is Ollama, and it's because of the ease of use, tons of integrations and development by the community, and the support of many different models that you can run in different environments. Now we're diving into LangChain, which is a very powerful framework that simplifies the process of building applications powered by LLMs and SLMs, and of course, any AI models. Now, this ecosystem or this framework called LangChain is extremely popular because it streamlines every single stage of the development lifecycle for AI applications, whether you're creating some sandbox environment at home and you want to optimize some task at your home and interact with vector databases, interact with different AI models, all the way to creating very sophisticated enterprise grade applications. LangChain integrates seamlessly with dozens of providers and technologies, making it versatile and robust for a wide range of use cases. At its core, basically, LangChain has a standard interface for working with LLMs, including OpenAI, Anthropic, open source models in Hugging Face, and so on, and even integrating with Ollama. You can use LangChain very easily with Ollama as well. Now, in the screen, you're seeing the LangChain architecture, where you have the library in the bottom. It also provides tools like LangGraph, which helps build stateful agents with advanced features like streaming and human-in-the-loop support, and many others. There are other components like Langsmith that allows you to monitor and evaluate your applications for continuous improvement. And throughout this course, we'll explore how to leverage LangChain, open source components, integrations, and orchestration frameworks to build intelligent systems, AI applications that are not only functional, right, but they're production ready, whether, again, you're just experimenting at home or deploying something at work as well. In my GitHub repository, I have dozens of resources related to LangChain. I have many different examples on how to use LangChain with vector databases, how to create embeddings, how to do cyclical workflows, and tutorials that are available, publicly and very openly, and also a lot of Jupyter notebooks that you can take advantage of for experimenting and deploying your AI application. Later in the course, you're going to see more examples of how to use LangChain with different environments, including vector databases, embedding models, and other frameworks. You're also going to be learning about Landsmith and Landgraph as well. In the next segment, we're going to talk about Llama Index, which is an alternative to LangChain. Now we're going to explore Llama Index, which is another framework that is designed to enhance the capabilities of large language models, or LLMs, by connecting them to custom and private data sources. In other words, actually deploying retrieval augmented generation and other implementations like chatbots, assistants, and so on. It is an alternative to LangChain as well, because it acts as a bridge between the LLMs and a diverse data formats such as PDF, databases, APIs, and more, and allows you to do a lot of function calling, tool calling, and so on for different automated cyclical workflows. At its core, Llama Index provides tools for data ingestion, for indexing, for querying. In other words, all the different components of a retrieval augmented generation pipeline. It allows you to create chatbots and also to extract insights from your documents and also to evaluate your implementation. So definitely this is another alternative. We're not going to go into a lot of details about Llama Index in this course. We're going to concentrate a little bit more with LangChain later in the course with a few examples because of popularity. So both of them are pretty popular in the community. I will say that probably LangChain is just a little bit more popular, and just because of time and because of the ease of use, I'm going to concentrate a few examples later in the course using LangChain. But again, there's a lot of documentation for Llama Index, a lot of tutorials, a lot of support from the community, and so on. So it's another alternative for an orchestration library, so you can integrate vector databases, embedding models, and your LLMs and SLMs as well. So let's go over what are embedding models, and simply put, they're tools, or of course, machine learning models that transform complex data like text, images, or audio into numerical representations called vector embeddings. And these vectors capture the meaning or the features of the data in a way that actually makes it easier for AI models to understand and process. So think about embeddings as maps where similar items are actually placed closer together, helping AI systems to actually find relationships and patterns between, again, whether it's an image, an audio file, text, and so on. So what you're seeing in the screen is basically a tool called the Embedding Projector by the TensorFlow community. And it's a really cool visualization of different words. You're actually seeing a whole bunch of bubbles in the screen, but if I hover over, you see that actually a lot of words appear in the screen. So I just randomly selected that word nutrition. So I'm going to click on it. And now what you're seeing is a representation of quote unquote the neighbors. So other words that are related to nutrition, whether it's health, metabolism, food, dietary, and so on. And you're actually seeing some points. And these are the nearest points in the original space. In this case, we're actually doing cosine similarity search or distance. And you also can do Euclidean. For the purpose of this course, we're not going to go into all the details of cosine versus Euclidean, but these are different techniques that have been used for quite some time, whether it's in search engines, recommendation systems, image recognition, sentiment analysis, and nowadays, of course, with large language models and modern implementations. Now, the magic in here lies on how embeddings simplify the high-dimensional data into a lower-dimensional vector while you're actually trying to preserve the meaning of the semantic meaning of those relationships. So again, in this case, the word nutrition and the relationship with it with other other words. So this is what actually the AI models also use to predict what is the next token in either in an image, an audio file, or of course in text. Now there are a lot of examples of very popular embedding models and their applications. What you're seeing here is something very simplistic. As a matter of fact, I just left the default, which is Word2Vec, and in this case is a 10K version of it. You can actually pull down from the menu and you see other ones in here. Word2Vec is a model that learns word embeddings based on the context using techniques like skipgram and continuous bang and a whole bunch of other terms that we're not going to actually cover here in the course for brevity. However, there are many others. There's the global vectors of word representations, or GLOVE. There's also contextualized embedding models like BERT, so bidirectional encoder representations for transformers, right? So these are a little bit more modern implementations that provides or produces context-aware embeddings by considering the words before and after a target word. So similar techniques are used by modern multimodal embedding models, including the OpenAI models, the Google's models, Cohere. There are many companies that actually produce embedding models. Now, there are a lot of embedding models in Hugging Face that are open weights that you can use for different operations, whether it's for clustering, for overall big text mining, classification, pair classification, re-ranking. And what this is doing is actually giving you a leaderboard based on an implementation called the Massive Text Embeddings Benchmark, or MTEB. And if you're interested to learning more about the Massive Text Embeddings Benchmark, or MTEB, feel free to actually visit and download this academic paper that I'm showing here in the screen. I also helped create a paper about selecting embedding models, and that can be accessed at the URL aisecurity.cisco.com. And if you scroll down, you're going to see different papers. One is around securing vector databases, and we're going to go over vector databases later in the course. And then there are some best practices around AI training environment security, as well as how to select embedding models. So if you click on that, we go over a lot of the details around the different terms of embedding models, examples of embedding models. This one is actually one from Cohere, and let me make this a little bit bigger here for you. And in there, actually, I have several examples on how I use embedding models for creating different types of applications, but specifically a lot of best practices on how vector embeddings work and how to select them, and specifically selecting embedding models with security in mind. And if you scroll down in this paper, I have tons and tons of examples, again, of different embedding model representations, and then some best practices around selecting and securing embedding models as well. So this is here for your reference, and you can access all these papers in the website aisecurity.cisco.com. Let's go over what are vector databases. Vector databases are so popular nowadays in many modern AI applications, especially whenever you are leveraging retrieval augmented generation, or RAG, and also in agentic implementations. But what are vector databases? At its core, vector databases, or a vector database, is a specialized system, a database that is designed to store and manage data in the form of vector embeddings. And you already learned that vector embeddings are numerical representations of data like text, images, or audio. And these vectors capture the semantic meaning of the data, then enabling you to do similarity search or semantic search that go beyond traditional keyword matching. So this makes vector databases very powerful for tasks requiring context and relevance to be given to an AI model, to then, of course, give you a better answer. Now, there are a whole bunch of different popular vector databases that are widely used in AI applications, agentic systems, and RAG systems. One of them is called Chroma. It's an open source vector database that is extremely easy to deploy, especially with orchestrations libraries like LangChain and LlamaIndex. Another one is the Facebook AI Similarity Search, or FIAS, which is a library rather than a full database, and is extremely popular for research setups and sandboxes, and especially since it allows you to leverage GPU accelerated similarity search. Another one that is also open source and very popular is called Weaviate, and it's an open source semantic search engine that definitely excels at handling unstructured data like text and images. And it also includes built-in modules for hybrid search capabilities, which are more advanced semantic search capabilities within vector databases. Melvus is another open source database that is designed for high performance similarity search. It supports a very large scale AI application integration with tools like TensorFlow and PyTorch and many others. And of course, you can also interact with it with the orchestration libraries like LangChain, LlamaIndex, and many others. Now, there are a few that are commercial. One that is extremely popular is the Mongo Atlas or the MongoDB Atlas vector search. Many companies use this vector database capability because it's extremely fast, it can scale significantly, and it's also driven by a cloud environment that is maintained by the MongoDB folks. So definitely that's probably one of the most popular ones in the commercial space. Another one is actually called Pinecone, and it's also a fully managed cloud-based solution, and it also can scale, and it has a lot of capabilities, ideals for applications requiring real-time retrieval. Now, in the screening here, you're seeing basically some code that I have in a GitHub repository for another training called Retrieval Augmented Generation for Cybersecurity. And I have tons and tons of examples in this GitHub repository, but specifically, I have a part here that is related to Retrieval Augmented Generation. And in this case, I'm creating vector embeddings using the OpenAI embeddings models, and then putting those embeddings from a file into a vector database. And in this case, the vector database is Chroma. I'm going to continue to add a lot of examples to this GitHub repository and also to the other repository that you learn about before in the training or earlier in the training. And again, technology is advancing so fast that what I do in order for me to scale is to put a lot of this information within the resources that I'm giving you here, which are living documents. These GitHub repositories are updated almost on a weekly basis, if not in a daily basis in some cases. So definitely take advantage of these examples, and especially as you are experiment and build labs and sandboxes, whether it's in the cloud or in an on-premise environment.